Draw a circle. Uh, that's not a circle but oval. Fine. Now measure its circumference and its diameter. Now divide the circumference by the diameter. For my sad oval, it'll be somewhere between 3 and 4. Okay, but if you drew a perfect circle and you measured with perfect precision, the answer would be pi 3.14159 forever. Never repeating, never ending. Now, here is the question. Did someone invent that number, or did we find it already there, waiting, woven in the shape of every circle that existed or will ever exist? You think you found it? I think pi was pi before first human opened their eyes, before the earth was formed, before the first star ignited. A circle's circumference divided by its diameter. Eternal, unchanging, discovered. And I think pi is a story we tell ourselves. A useful story, the most useful story in human history, but still a story. Okay, then let's settle this. No, we won't. Mathematicians and philosophers have been fighting about this for 2000 years, but I'll enjoy watching you try. 1960, physicist Eugene Wigner writes a paper titled The Unreasonable Effectiveness of Mathematics in the Natural Sciences. His argument is simple and devastating. We invent abstract mathematics, often with no practical purposes. Then, decades or centuries later, it turns out to describe the mathematical universe perfectly. Give me an example. Okay, non-Euclidean geometry. Bernard Riemann, 1854, he bent space into curved shapes. Pure play, no application. He was exploring the what-if scenarios. What if parallel lines could meet? What if triangles had more than 180 degrees? 60 years later, Einstein needed mathematics for curved space-time. And he got Riemann's plaything sitting on a shelf, waiting. That's interesting, but it's not a proof. Okay, conic sections. Apollonius of Perga, 2000 years before anyone had a use for them. And then Kepler discovered that planets move in ellipses. The math was already there. Group theory, developed in 1830s to solve polynomial equations. A centuries later, it became the language of particle physics. Quarks are organized by group theory. The mathematics of symmetry, developed for algebra, turns out to be mathematics of reality. Okay, so math is unreasonably effective. But what does that prove? Well, it proves that mathematics doesn't act like something we invented. If I invented a hammer, it's good for hitting things. It's not good for composing music, predicting the weather, or describing the orbit of Jupiter. But the mathematics, invented for one purpose, keeps turning out to be the exact language of the universe for purposes no one has anticipated. That's not what an invention does. That's what a discovery does. Take prime examples 2, 3, 5, 7, 11, 13, 17, and so on. Indivisible. The atoms of arithmetic. Did we choose what numbers are prime? Obviously not. No. They are prime whether we like it or not. They were prime before humans existed. They would be prime in a universe with no life at all. The distribution of primes follows laws, the prime number theorem, that we discovered painstakingly. We did not legislate them. Cicadas. Some species emerge in every 13 years, others every 17 years. Prime numbers. Evolution discovered primes because they minimized overlap with predators. The prime numbers were there, doing their thing, before we even named them. That only proves arithmetic has structure, not that mathematics is discovered. Okay, let's go back to 1980. Mandelbrot is playing with a simple equation. Z equals z squared plus c. Feed the output back in over and over. Plot which points stay bounded and which scapes to infinity. And he gets this. This shape, infinitely complex. Zoom in and you'll find smaller copies of the whole. Zoom in further, spirals, seahorses, electric storms of geometry. None of it was designed. None of it was intended. Mandelbrot did not know what his equations would produce. He found it. He defined the equation, and that's an invention. He defined the rules. Then the rules revealed the world he did not build and could not have imagined. The Mandelbrot set was already there. waiting in the logical space of that equation for all eternity. Before any human existed, Mandelbrot was the first person to see it. He didn't make it, he discovered it. Like Columbus didn't make America, he discovered America. Oh, the Columbus metaphor? Bold. Well, I stand by it. Alright, my turn. This is a map, not a table. It's not a room. It's a representation, simplified, abstracted, useful. Mathematics is a map. Reality is a territory, and you're confusing the two. There's a difference between a map and math. A map is obviously invented. Math is... let me finish. You say pi was pi before humans. Fine. The ratio of circumference to diameter exists in nature, but 3.14159, that's a notation, a human notation. A number exists in concept only because we have a concept of number. A circle in nature doesn't have a circumference that's exactly pi times its diameter. A real circle drawn in ink or orbit of a planet is never perfect. Pi describes an ideal circle, and the ideal exists only in our minds. So numbers are just opinions. Numbers are language, and languages are invented. Different cultures count differently. The Babylonians used base 60, and that's why we have 60 seconds in a minute, 60 minutes in an hour. They didn't discover base 60, they chose it. Probably because 60 divides evenly by 2, 3, 4, 5, 6, 10, 12, 15, 20. The Mayans used base 20. Computers use base 2. And none of these are true. They're just conventions. Useful ones, but still conventions. That's notation, not mathematics itself. 2 plus 2 equals 4, whether you write in Arabic numerals, Roman numerals, or tally marks on a cave wall. Okay, but here's the real problem. Mathematics rest on axioms, and axioms are chosen. They're not discovered. They are rules we agree to play by. Euclidean geometry have 5 axioms. Change the 5th, the parallel postulate, and you get entirely different geometries. Riemann hyperbolic. All 3 are internally consistent. All 3 are mathematically valid. Which one describes our universe? That's a physical question, not a mathematical one. The axiom of set theory, there are multiple versions. ZFC, ZF with choice, ZF without choice. Mathematicians actively debate which axioms are correct. If math is discovered, how can we be arguing about rules? Oh, touche. Thank you. And let me ask you, aliens, somewhere in Andromeda, they do what we do, recognized as mathematics. But what does their math look like? I think their prime would be same as ours. I agree, primes probably, maybe, but their mathematics as a system, their notations, their axioms, their choices about what to study. They might not have invented 0 as a number, plenty of human civilizations didn't. They might have calculus or not. They might have something richer. They might have skipped geometry and gone straight to trigonometry. Their mathematics might be built around concepts we can't even name. If math is discovered, if it's a single eternal truth, then all mathematics should converge towards the same thing. But it doesn't even converge on Earth. And that's actually a good point. Don't sound so surprised. Okay, let me reframe it. There's a distinction between applied math and pure mathematics. Applied mathematics, calculating bridge loads, modeling fluid dynamics, that's clearly a tool, and tools are invented. But pure mathematics, the study of mathematical objects for their own sake. That feels different. When Andrew Wiles proved Fermat's last theorem in 1994 after 358 years of mathematics following, he didn't build the proof, he excavated it. It was there in the logical space, whether he found it or not. He didn't create a connection between elliptic curves and modular forms. He discovered a connection that was always there. But here's the problem with that view. If mathematical objects exist in some eternal Platonic realm, then where is this realm? What does it mean to exist without space, without time, without physical instantiation? So you're a physicist. You believe in things you can measure. So where do I put my detector to measure prime numbers? Not everything real is physical. Is love physical? Is justice physical? You can't put a detector on justice, but you feel its consequences. That's a category error, and you know it. Is it? The Platonist position is modest. It says mathematical truths are like logical truths. If A equals B and B equals C, then A equals C. Now, that's not a human invention. It's a constraint on coherent thoughts. It's true whether humans exist or not. Okay, let me return to Wigner. His argument is stronger than I made it sound. It's not just that mathematics works, it's that it works miraculously well. Newton's law of gravitation is one-line equation. It predicts the motion of planets, moons, comets, tides with astonishing precision. One line. Why should universe obey one-line equation? Maxwell's equation, 4 equations, they unify electricity, magnetism and light. They predicted radio waves way before anyone builds a radio. They predicted the speed of light from pure mathematics. 4 equations that fit on a t-shirt. Why does universe speak mathematics? Why isn't it messier? Why isn't it unspeakable? Because we choose the mathematics that fits. You don't remember the thousands of equations that didn't work. You celebrate the few that did. That's survivorship bias. But the few that did work, they worked too well. General relativity predicted black holes. Einstein didn't believe in black holes. He thought they were mathematical artifact. But the math was right and he was wrong. The math knew. Well, the math didn't know anything. The math was a model. And for black holes, the model made a prediction that turned out to be correct. That happens with all models. Weather models predict hurricanes. They are not discovered. They are built. They are invented. They are useful fictions. But a weather model doesn't predict things it's created, it didn't believe in. Einstein didn't believe in black holes. Maxwell didn't believe in radio waves. The weather model didn't believe in hurricanes. All right, that's not the best analogy. Got one. Okay, let's take a step back. Why does this debate even matter? Math works whether you think you discovered or you invented it. Bridges hold, rockets fly, Wi-Fi connects. It matters because it changes how we do science. If math is discovered, then we should trust it. When math says that something contradicts our intuition, then the math is probably right. Black holes, quantum entanglement, time dilation, all of these were crazy math before they were obvious physics. If math is invented, then we should be more skeptical. It's a tool, and tools break. Tools have limits. So you're saying that this invention position is making you more cautious? It makes me more humble. String theory is beautiful mathematics. Decades of it, elegant, consistent, profound. Also, zero experimental evidence. Supersymmetry, same story. Beautiful math? Nothing more than that. Nature seems uninterested. If you think math is discovered, a window into ultimate reality, then beautiful math must be true. If you think math is invented, then beautiful math can be a beautiful fantasy. I agree. String theory might be the most expensive consequences of Plantism in human history. Thousands of careers, billions of dollars built on the faith that mathematical elegant theories are discovered rather than invented models. If they'd be more skeptical of their own math, they might have been more skeptical of their own math. But here's the thing, both views contain wonder. If math is discovered, then we are explorers in an infinite landscape. Every proof is a new continent. Every theorem is a mountain we climbed to see further. The truths were always there. We're just the first to reach them. If math is invented, then human mind is capable of building a cathedral so vast, so precise, so perfectly fitted to reality that it can describe galaxies and quarks with the same equation. We made this and it works. That's not less wondrous. It might be more. That's unexpectedly generous. I contain multitudes. Don't push it. But there is a third view from philosopher's view, asking, is math discovered or invented? Like asking, is hammer discovered or invented? A hammer is invented, but the fact that hammers work, that solid objects can transfer force, is discovered. The hammer is invented, the physics behind it is discovered. Mathematics might be like that. The symbol, the axioms, the systems invented, like the hammer. But the logical relationships that make those systems powerful, discovered, like physics. So it's both. It's both or it's neither. And that's the most philosopher answer I've ever heard. Thank you. That wasn't a compliment. So, here's what I actually believe. I believe pi would be still pi if humanity never existed. I believe the primes would be still primes. I believe the Mandelbrot set was waiting to be discovered. And I believe that's extraordinary, that the universe is built on mathematical foundations we can discover but did not create. And here is what I believe. Mathematics is the greatest story humans ever told. We invented a language so powerful it can describe black holes we have never visited and particles we'll never see. We are told the story of calculus and suddenly we could predict eclipses. We told the story of group theory and suddenly the quarks fell into line. It's not less beautiful because we made it up. 2000 years of debate and no winner. And no loser either because the mathematics works either way. I think that's actually a miracle. Whether we discovered it or invented it, it works every time, in every domain, at every scale, from the Planck length to observable universe. That's the closing line, and you know it. Draw a better circle next time. Next time, you draw it.